Welcome to our Disassembler presentation. We're Team Terminal. I'm Jaden, and I'm going to be starting us off today. So if we move to the next slide here, we were able to complete all the required opcodes, as you can see on screen. This includes the three conditions of BCC specified below, so BLT, BGE, and BEQ. Obviously, multiply sign .l is not supported because that is only on some 68K processors. We are also able to complete all the required addressing modes. This includes data direct, the various address registers, indirect, absolute addressing, and immediate data. We also have a checker for addressing modes to ensure that the different addressing modes are correct for each individual opcode. For example, we don't allow functions to be called with immediate data as the destination because you can't store in immediate data. Any invalid opcode or invalid addressing mode will automatically print out just the data that was there. So it won't print out an opcode if it's not valid. In terms of I/O, if you move to the next slide here, we implemented everything required. As you can see at the beginning, it goes over the various formatting things you should expect when entering starting and ending addresses. It prints 10 lines at a time, and then you have to hit enter to print 10 more lines. We think it's very nice. It prints one screen at a time so that you can view each memory location individually, but you can still view only one screen at a time. It properly questions the user at the end if they would like to restart and do it again, and it'll ask them the same questions it did up here, and you can do it again with starting and ending addresses, and it'll repeat the process. Next, Gabe will talk about our process workflow.
Hi, all. I'm Gabriel Acuna. So regarding teamwork, in order to get the I/O opcodes and effective addresses all completed as specified by the assignment spec, we use Trello for workflow. We created to-do cards to create tasks which were picked up by teammates to be completed and moved down through the line until they were finished. To further check how we were doing, we also met weekly to discuss issues or general progress. And I would say the closest software development process we followed would be somewhere along the lines of Agile Kanban. Next slide, please. And regarding a list of incomplete tasks, our team was fortunate to not have any tasks that we weren't able to tackle. That is not to say we did not struggle at all. Some opcodes were definitely more difficult to program than others. I would give a lot of credit to of our success with this program to team communication and rigorous testing. But my teammate Lou will now talk about one operations that was quite difficult to figure out. Next slide.
Okay, so personally, I think move M is very tricky and confusing. The idea was simple. First, we determine the direction of the transfer. It could be either register to memory or memory to register. And then we check the addressing mode, which could be decrement or increment. Then we loop through the next 2 bytes to add all the registers to the output. However, when I started writing the code, I've made a lot of small mistakes, such as shifting the wrong bytes or using the wrong subroutines for the for loops. And also for memory to register, I had a very terrible algorithm. So I had to step forward, put the extension, step backward to read the register list, and then step forward again. I spent like more than 20 hours on this subroutine, and finally, uh, we had it working. Next slide.
And most of the observed bugs, there weren't really any bugs with Easy68k, yet it doesn't really reach its full potential as a software. Some simple features, like scrolling through the output or just being able to copy from the output screen, aren't doable. So I wouldn't say we observed any bugs, but there is a lot of room for growth. Next slide.
And then now we're going to do the demo here. So now move on to the demo. We're prompted for a starting address here, which is going to be 9,000. So we're going to type in the 4 zeros there. And then the ending address, which is 92CE. And then here we have the starting address 9,000, and we have all the opcodes here. So we're just going to scroll through these fast. See that they're all here. And so for move A here, this is an opcode that was not required by the specification, but we still have it in for testing purposes, but it shows us best data here. And we'll see that for some other opcodes coming up as well. Add A there. It's not required. DIVU is not required as well. And then for BCC, only BLT, BGE, and BEQ were required. So the others will show up as data here. And then finally, we have JSR, RTS, and BRA. And at the end, it'll ask if we want to disassemble it again. So we can type yes or no, and I'll just type yes here so we can see. And now it'll prompt us for the starting address again. So that is our disassembler output. Thank you very much.
Thank you.